All right, everybody. Welcome to the wasmCloud community meeting for Wednesday, April 26th. We are all back from KubeCon with a force, and I think we have a pretty fun agenda for today. Let me go ahead and share my screen, and we can get started. So I'm sharing my whole screen because I'm going to hijack it right after we get done with the agenda. But what we're going to talk about today, we're going to see a little demo and do a discussion on the wasmCloud Application Deployment Manager, or WADM, the declarative application format, the open application model, and where we're at with the 0.4 release there. We're going to talk all things WADM. And then after that, we have another discussion we have queued up from Stephen. We're all going to chat about the built-in number gen capability, what it means in a cryptographic context, and what this may look like for generating random bytes. And then also with all the things coming out of KubeCon, we're going to do a little wrap up there, and I have all the video recording links, including the playlist from the whole Cloud Native WASM Day and the links to almost everybody's talk. We're still waiting on Kevin's to get published from the main conference. So without further ado, I think we can go ahead and get started. I'm going to be leading this first part on WADM. I talked about it a little bit last week, but it was on the conference floor and a little bit flurried. So I wanted to bring it up again in a context where everybody can see it and ask questions, and I can have a little bit more of a brain to explain it. So some of us on the wasmCloud maintainer side have been working really hard on bringing WADM to a 0.4 release, which is essentially reworked and redesigned using Rust, using NATS Jetstream as a store, and really making sure that this is tidied and productionized so that people can start using this to run and manage their wasmCloud applications. So if you haven't heard of this project before, the overall TLDR on what this is most useful for is making sure that you can declaratively manage wasmCloud applications across an entire lattice. And so this works alongside existing wasmCloud tools that essentially hooks into a NATS connection, the same one that your wasmCloud host's using. And then it will survey the lattice for the entire state of like all the different hosts and actors and providers that are running. But what this really means for you, or you as a developer, is that you can define your applications in terms of a common format. This is the open application model. I guess I might as well just pull that up. But this is another open standard, kind of like how we use the Open Container Initiative, or OCI, for our artifacts. OAM just makes sense for us to use this to define applications. So using this model, you can define a wasmCloud app. It's got some general things. It's an application, name and version. We support multiple versions of applications, and I'll show you an example of that. But the real magic comes in the components section. So you can define a list of components that are either actors or capabilities. And then as a part of those components, you can define a spread property or a spread trait, which you can define like a scale or the amount or kinds of different hosts you'd like to spread across. You can also define link definitions, which is where you can essentially stitch these components together or stitch these wasmCloud actors together and give configuration. So you'll recognize this echo actor. You may have seen essentially this, but in an imperative context, like wash control start echo and start HTTP server, and then link echo to HTTP server. What's really nice with this is with WADM, you can define this declarative manifest and essentially say, hey, WADM, please go make this the state of my lattice. And this is a really familiar model for people to manage applications. This is exactly how people work with Kubernetes deployments. And if there's anything that Kubernetes did really, really well, and anything that people like, it's being able to declaratively say, here is the way that I want things to be. Please go make it happen. I don't care how. I just want to have an application running. So moving forward, I'd like to actually show you what this looks like, and then go through a couple of examples in a demo, and then we can kind of move on to questions, discussion, all that kind of stuff. So this is currently in an alpha state. we do have a release here. So, and there's some instructions that we're even making easier. You can use Wadum and Wash together. But I'm going to show essentially from this branch of Wash what this looks like. So now, as a part of running Wash up, you may catch it really quick. Wadum starts up really fast, but we actually start or download and start the Wadum binary when you run Wash up. And it's just a Rust binary. So there's nothing super special there. And if you go to localhost 4000, you'll see I left that over. You'll see a couple of the wasmCloud dashboard as you're used to seeing it. But now, if we want to take a look at if we want to interact with Wadum, we can actually do that through Wash. So if you do Wash app list, it'll tell you all the applications that you have managed. Of course, that's going to be empty. So let's start with our echo. If we, I actually put in a PR a little earlier that's now merged into the wasmCloud examples repo. So all of the actor examples now have this Wadum YAML file. If we look at that, it's actually a little dark. I don't know if that shows up well. Essentially got the same thing from the example or from the documentation here in the examples repo. So what we can actually do is we can just do a straight up wash app deploy Wadum, and this will take that manifest, put it, and then deploy it. And those verbs are intentionally different, but I'll talk a little bit more about it later. But when you do wash app deploy Wadum, Wadum will then tell your host exactly what it needs to start in order to make that application a reality. So you'll see Echo starts up, then HTTP server starts up, and then as soon as that shows up as healthy, we link them together with the defined link definition. And so that we can actually take a look at is actually on port 8080. And if we go look at port 8080, ta-da, you can see that we have our Echo application. So without doing any of the drop downs or wash control start type commands, we have now deployed the Echo application, which is really sweet. It's really nice to be able to say, hey, go make this a reality, and then you now have an application running. So in terms of the other things that Wash or that Wadum can do, if we take a look at the applications that are listed, this is actually something that we need to fix, but we have the one Echo example. If we wanted to make a change to this, application, we can come in, we can bump this version to 002, and then we could do something like make sure that there are 3 replicas running in this for this Echo actor. And I mentioned the difference between put and deploy, but what you can actually, this might just work. Let me try this. We deploy Wadum, this will actually put the newest version of the application. And then if we take a look at the app list, we're going to say we're on 002. And you can see that we actually went up a little past 3. This is part of the alpha release and something that we're okay with. We can essentially converge on the proper state a little bit over time. So Wadum actually has the ability to manage multiple different versions of applications, and you can update them, you can roll back by putting a newer version, all those things. Additionally, what you can do is undeploy. So if you have an application like this, you can undeploy it, and it will remove all those resources out of the lattice. So let me show you something. One of the examples is a little bit more complicated. We take a look at the animal image downloader example. And if you haven't seen this one before, this is one actor that has, we're just running one instance of it, but we're linking to HTTP client, blob store, and messaging, and we're starting those 3 capability providers. So starting this normally is a little cumbersome, but with Wash app, we can just deploy that manifest. And this will essentially go do the same thing, tell the host to start all of these resources. And then as soon as this goes healthy, we should see that they come across. Now, actually using this application, we can do a request to wasmCloud.animal.dog. And this is what the application just does. Oh no, I messed something up here with the actual application. Okay, I might have had a wasmCloud host running in the background for this one anyways. Anyways, the point of this is that you can really easily manage your applications in this way. And so if we undeploy animal, this will remove all those resources out of the lattice. So what we're going to be asking people to do as we keep working on Wash and Wadum, we're going to be pushing towards an official 0.4 release once we work out some of the smaller kinks in Wadum as we're actually getting to test it. But what we essentially want to do is give people a way to run all the wasmCloud examples with just that one command, wash app deploy, and then the actual manifest for the example, and that makes it really easy. So that was kind of a lot with the demo and talking about Wadum. Does anybody have any questions or things that they'd like to discuss around the project and the format?
Brooks, when am I going to be able to use it? Can I use it today?
Well, you can use it today. I have a PR open in Wash right now. Let me go ahead and bring that up really quick. I got a PR open in Wash that adds support for Wadum. So this will actually, when you run Wash up, it will run Wadum, and then it's ready for you to use the Wash app subcommands. I'll go ahead and send that in the chat. So if you'd like to install from this link, it's going to be version 0.18. You can get playing now with any of our examples that are in the examples repo. Yeah, Kevin.
So I was wondering if you could show what happens if you accidentally turn off or accidentally stop one of the capability providers that's managed by your Wadum application.
Oh yeah, let me go ahead and do that. So if I take a look back, I'm going to share this. So I went ahead and I just deployed the same application again. So I deployed the animal example. And so if you come to any of these, so Wadum not only starts these things initially, it also ensures that the state of the lattice reflects this application over time. So if you were to take one of these actors and you were to delete this animal image downloader out of the lattice, there's a certain cooldown period, but essentially what happens is that, or I'll do the same with HTTP client, Wadum will take them, will calculate the difference in state and see, hey, that this application is supposed to be running an HTTP client and an animal image actor, and we'll restart that resource in the lattice. We can do this for any of the providers. We can do this for the link definitions as well. The actor, there it goes. Essentially what we have is a cooldown period. And so we're kind of working on tweaking that to make it pretty seamless, but we don't want to issue too many commands at the same time. But this is really nice because it can cover things happening over time. If you accidentally were to go and stop one of these resources, Wadum will make sure that it's still running for that. Yeah, it's pretty sweet to watch. I'll talk over one other edge case as well, because you could be using something like the animal image downloader for multiple different applications in your lattice. And Wadum is only responsible for managing the resources that it deploys. So if I deploy extra instances of this animal image downloader, you'll see that Wadum isn't going to stop them. And that's actually on purpose. So the one instance of animal image downloader that's managed by Wadum, it can see that it's running, and the 4 extra instances that I started on my own are essentially unaffiliated with that application. And that becomes really important when you start thinking about running like multiple HTTP servers or running multiple applications that may use the same actors. They don't conflict with each other, which is really neat. So we can kind of scale this back down. Yeah, Stephen.
Information about what's happening can be seeked from OpenTelemetry data, right?
Yeah, so based on the You can take a look at what Wadham is actually doing. If you turn on the Rust logs to a more verbose level, you can kind of get an idea of what each scaler is doing within Wadham. But yeah, you're exactly right. You can also supply an open telemetry endpoint to Wadham, and it'll export all of those traces. I actually haven't given that a try with the full washup suite, but it should work the same as wasmCloud as well. That'll be really interesting for keeping track of what the app is doing over time. Alrighty. Well, yeah, we're super excited about Wadham and what it's going to do for some of the introductory tutorials, and what it's going to look like for managing applications in wasmCloud. It's a really, whether or not you like YAML, which you can use JSON if you really dislike using YAML. Whether or not you like the actual format of doing that, it's really familiar for people who are coming from a cloud native context to write declarative manifests. And I think that this is going to really make approaching the ecosystem a little easier, starting with a format that people are familiar with, and then seeing a lot of examples how you can kind of stitch that together. So we're really excited. We're probably going to do weekly or so check-ins on Wadham as we lead up to an official 0.4 release. And if anyone is interested in taking a look and contributing, we have a couple of issues now in the Wadham repo that have the good first issue tag. At least one, I remember tagging one. Yeah. Couple of issues that have the good first issue tag. This project is completely written in Rust. So if you're interested in contributing, these are great ones to take. Just feel free to come in and leave a comment and let us know that you're interested in working on it, because we're definitely accepting contributors at this point now that we've pushed to the first alpha release. All right. Any other questions before we move on to the next part of the meeting? All right.
Oh,
sweet.
Yeah. You asked me to give an intro. Yeah. Hi. Sorry for stepping in late. I just got the link. You asked me to give a short intro. So I'm Jochen. Hi. I met the whole team, I think, at the KubeCon, which was pretty exciting. I work for Machine Metrics, which is a IIoT platform. So we collect data from machines, and so I'm pretty much interested in how that all plays out, because we use NATs, we use cloud events, use all the underlying technology already for our data streaming. So might be a good fit. And I'm just gonna look a little bit into how you operate, how that works, and setting up some demos for internal users.
Nice. Well, yeah, thank you so much. It was great talking to you on the floor last week. Yeah, that's how time works. Last week, and thank you so much for joining the call. It's great to have more people in here.
Mm-hmm.
All right. Well, I know that the next thing on our agenda, I can go ahead and share that again. The next thing on our agenda is to talk a little bit about the wasmCloud built-in number capability, and its applications to cryptography, and then specifically the contribution from Stephen generating random bytes. And so you may have seen a couple of PRs go out. I'll just share part of this one, Stephen, and feel free to jump in if you wanted to add a little annotation here. But this PR adds in one more function into the built-in number gen interface, which is random bytes. And so essentially what this does is you give it a certain number of bytes, and then the wasmCloud host is responsible for generating kind of a list of those bytes. And this specifically ended up being useful for, or would be useful for someone like Stephen for cryptographically generating some random amount of information. Now, we have a couple of operations that do similar things, like random 32 generates a random 32-bit number. But I think in this case, Stephen needed like 256 bits of random information. So in lieu of just like looping and doing that 6 times or so, kind of adding a generic function to this. So we talked in Slack a little bit. There's a few things around like how we need to bump and version this interface, but what I really think we started talking about and would be a valuable use of time here is to talk about the built-in number gen interface and its application to cryptographically safe random numbers. Let's see. I think I'd like to ask Kevin if you could elaborate a little bit on the way that we have the built-in number gen interface now, like what it's designed for, and then we can go for there.
Yeah, it's probably not all that obvious from the evolution of it over time, but the built-in interfaces are designed specifically for, I guess, what I would call best effort in functionality. So if you need a GUID, for example, then what you'll get is a cheap and easy to create GUID. We don't give you the monotonically increasing time sortable GUIDs. We just give you a random number. Same thing with the regular random numbers is they're random, but the host and the interface itself makes no guarantee that it's cryptographically random. So we're not taking any extra measures to make sure that the random numbers that this thing gives you are usable for cryptography. So I think where this ends up having the conversation is, excuse me, where the conversation ends up is it the responsibility of the built-ins to give you numbers that are suitable for cryptography, or should we have a separate provider / separate interface to expose information that or data that is suitable for use in cryptography? The super short version is that there are extra measures that a random number generator needs to take in order to give you what's called a cryptographically safe random number. And so I'm oversimplifying, but those are more random than regular random numbers. And so, yeah, what I'd like to open the floor for in terms of discussion is the philosophical difference between what numbers should be provided by the built-in and which ones we think should be provided by separate providers. Yeah, go ahead, Stephen.
Yeah, that's kind of where I get stuck, is I'm not sure the best approach to generate those numbers, because I was even thinking out on my walk today, I was wondering if WASI is at a point where I could be doing that in an actor, and I'm not sure if that would ever be a thing or not. I've never thought about the provider aspect, so it's good to note that the number gen isn't meant to do those things, because from like a user perspective, that's what I was kind of thinking it was for. And I wouldn't be opposed to using a provider to do that if it was, you're looking for like a more pseudo-random cryptographical number. And then realistically, you could probably use some crates that exist already. But I was looking at the Elixir or Erlang modules, and there's one called Crypto, and I wasn't too sure how cryptographically secure that was. But that's kind of what I was looking into when I was adding the random bytes thing. And then another thing I also had difficulty with from a user perspective is sometimes when you're generating these numbers, I think a lot of crates refer to like these numbers by bits. And then because in the Rust world, we're kind of referring to them as bytes, and a bit of my ignorance too, just not understanding it completely. You get a little muddled thinking about it as bits and bytes. So it's like, am I requesting this many bits, but because Rust is using ASCII characters and we have to request bytes, like it gets a little bit muddled from a user's perspective. So I think for me, I'm not so concerned where I generate this number as long as I know how to generate it and like what information I'm requesting.
So I raised my hand. Unfortunately, not to give too much more clarity into this, but to ask kind of another question, because I know that through WASI or wasmTime, there is a way to get a random number, or at least in theory. I guess to help fill in the ignorance. Bailey, can you help me out there? Yeah, okay. In theory, there's something called WASI crypto. I'm trying to keep in mind all these things that we have built-ins, and in the Erlang or in the Elixir host, we're kind of giving best effort random numbers. We could kind of upgrade that to more cryptographically secure functions, but I think it's just part of the reason is that that's a complicated assertion to make. And so I'm looking for ways for us to leverage the WASI functions. And so if that's kind of still in proposal state, maybe that's not something that we can quite use yet. I know Jordan is next, but maybe Bailey, if you're responding directly to me.
Respond to that, yeah.
Do it.
Okay.
Yeah.
So WASI crypto does have real implementations in places. People are using it. Other people, like some people I know, have used it and run into some friction. It's pretty hard if you're trying to do things that really rely on things like OpenSSL. So I don't think the path is smooth yet. When there are WASI interfaces for things, that doesn't necessarily mean that there is a WASI implementation for said thing. And so we need RFCs and work to happen, like, for example, within the Bytecode Alliance RFCs repo, to say this is how we think WASI crypto should be pluggable in these other systems. But I mean, if you search for wasmTime and see it, it looks like it should work, but I can't speak to it. And all I can speak to is I see a lot of friction and issues that get reported.
Okay, cool. Yeah, because I would love for us to, go into the future and be able to use WASI level APIs. Like if you're using Rust and you import the rand crate and you generate a random number using that, and it's compatible with WebAssembly because it delegates that syscall to a lower level, I think that's an ideal future. It sounds like for now, we're probably best off either using the built-in number gen or creating a crypto interface and then having a provider implement that. But, move on from there. All right. I've cut Jordan off enough times. I'll let him go.
I forgot what I was going to say. I'm joking. No, so my input is on the topic is not specific to crypto or anything, but from the perspective of like a host, right? I think we need to take into consideration, like we're all running them on MacBooks now, but eventually if we're on like an ESP32, will it ever have enough entropy to give you a true random number? The answer is no. So I would think it's like in the platform's best interest to not get in the business of cryptography specifically, right? That's those are strong words, and people, and if you say we give you a cryptographic number in our host, you're signing up for a lot. So I would argue that this is 100% a provider's job outside the internal one, which is good for like prototyping. That's my 2 cents.
Yeah, Jordan pretty much said it better than I could have. For a number of reasons, putting cryptography support into the built-in contract carries with it a number of implications. So if you were to add that crypto stuff to the built-in interface, then people assume that all of the hosts have that support built in. And like I mentioned in chat, adding that to the Elixir host actually affects how portable that host is, where it can run easily, and what the installation prerequisites are. And again, to Jordan's point, it's a really big can of worms. Even things like asking for a set of random bytes, depending on which crypto modules and libraries you're using, some of those take 5, 10, 15 input parameters for how it's supposed to work, which algorithm it's supposed to use, and so on. And so the short version is the wasmCloud host should not be in the business of doing cryptography, because that's best left to people who know what they're doing.
Was your hand up first, Brooks?
No, I think you beat me, but we may go to the same thing.
Sorry, I was looking up a link. So like I'm 100% on board with like having to use a provider if that's the recommendation. But I think I might have missed, like I might be not looking at this from the correct context, but is there a way we could add language around number gen to make sure it's explicit that for number generation, it's mostly meant for maybe prototyping or something. And then if you want to be generated, like I didn't even know that about the GUIDs, that it wasn't time sortable. So like, that's really great to know. And like the Rust rand crate gives you access to all kinds of pseudo-random number generators like cha-cha-20, and you can choose. So it's like, I think it's valuable to be able to have a provider for that and be able to swap it around, and then you don't have to worry about it in the host. I'm just concerned about a user's perspective, looking at number gen and seeing, oh, this is something I'm going to compare to rand, and that's all.
Yeah, I'm just going to skip the line real quick and add that it's a great idea to have those guarantees or lack thereof documented. So I think what we're going to want to do is make sure that in the built-in interface, we can add documentation right on top of the Smithy, which will make its way into the code gen. So we can make sure that those guarantees are in there.
Yeah, we have to be really, I guess just general note, we have to be really careful around any documentation we put in the interface itself, because it's inherently not tied to any implementation. So for the built-in, most people are going to be using the OTP host, but with multiple different hosts possibly being places that you can run wasmCloud actors. Different hosts may have different implementations, as Jordan was alluding to. So I think what we should do in the built-in interface, and then in the cryptography interface that we'll probably talk about here in a second, or a proof of concept, we should always make the note that the interface itself makes no guarantees around cryptographic viability, and then the actual implementation is the one that has to do that. So with that, I think we have one action item to come out with documenting the interfaces more thoroughly around their purpose. And then I just want to make sure that we loop back, and then Bailey, I'll come back to you. I want to make sure that Stephen, you have what you need to move forward for your use, because I think you're still going to be generating these random numbers, whether or not you need them to be truly random or not. So I would propose that we leave the built-in interface as is, and we take advantage of a provider interface in order to have bigger flexibility. And if we wanted to start that with just the random bytes function that you were contributing, I think that sounds great. We can start it out simple, and then it is welcome to, kind of change over time, because it's an example or something that we're working on. How does that sound as a path forward? So we have that separate interface and then a new capability provider for, we can call it crypto, we could call it, example crypto. We can figure out those kind of details later, but that implementation actually does the random number generation. Does that sound good, Stephen?
Oh yeah, I was. If we're going to be doing, maybe we can maybe start this as a spike and just investigate that WASI crypto and a provider. Like, if I have to make something, might as well just see if it's possible, and then maybe don't have to worry so much about using WASI in the future if it's possible to get there now and it's not going to give too much headache.
Yeah, love that idea.
Cool.
And that's around what I was raising my hand for. So we've talked a lot tactically about what's available today, right? And it seems the today answer, like right now, write a provider. But I did want to clarify that, and I guess this is more brainstorming. What we should have, right, is in the wasmCloud repo, we should have an implementation of WASI crypto. I don't think it should be a built-in per se. I think it should be a WASI fill, kind of similar to what we showed off at the wasmIO demo, where we were able to supply a key value implementation that was actually distributed and lived somewhere else. For all the reasons that we've talked about, for portability and entropy and all those kind of things. And so I'm saying maybe we toss out a GitHub issue that we spike on for implement WASI crypto for the wasmCloud host. Because right now we don't turn on that flag or anything. So yeah, we don't support it, but we totally could. And I think a lot of people are building stuff for it. And it's something that Colin from Adobe wanted as well.
Bailey, can you just maybe explain your thinking a little more clearly on why you think this should be a WASI fill? I know there's that great blog post that Kevin, I think you pulled together and put up on the Cosmonic blog. I'll link that into the chat here, but maybe just make sure that people understand the pattern that you're putting forward there and why you think that's the right path forward.
Yeah, so, I'm like nervous to declare expertise in cryptography because that field is deep. But from what I understand, there is a concern about if we had a host that was running as a built-in on an IoT type device, would we have the level of entropy that we need for random numbers? I don't know. Could be no. Could be that we want that to be something that runs somewhere else. And the reason why I want us to use a technique of a WASI fill is that we can let you write your code just like you would in any other environment, following the documentation like, hey, WASI crypto is the right way to do this type of thing with WebAssembly components. Build your component just like you would normally do. We take that off-the-shelf component, and when it runs in wasmCloud, we handle the distribution for you. And make sure that we're using that capability in the right environment so that we have the right level of entropy and all that type of stuff. I hope that's clear. And if you haven't seen it, I totally read Kevin's blog post on that topic. I really appreciated him writing that.
That's super cool, Bailey. Thank you for explaining that.
Can I get a volunteer for someone to lead up writing that issue, either in the wasmCloud repo? Bailey, all right. Bailey, it is officially assigned to you. So we'll get that issue. I'm really interested in following that one and hopefully helping. And we'll go from there. Stephen definitely signed up. Cool. I wanted to shout out one more quick thing. We actually have in our examples repository this crypto directory that has a couple of cryptography examples. And as mentioned, it's using the built-in number gen capability. So it's not something that's explicitly cryptographically guaranteed to be random. But these are some really two really sweet examples for signing a payload and verifying a signature. I believe Steve wrote these up and put them in our examples repo. But these are really awesome for a couple examples. If you wanted to take a look here, I guess I'll send this in the chat as well. Wanted to at least shout that out if people were looking for other places or an actual example that exists now.
Actually, Brooks, do you mind pulling up 2 slides? I thought of another reason why WASI is really valuable here in this use case. I don't know if you can get access to that one. Oh, you
if you've got it, yeah, you got power, so you can share.
Okay, cool. I totally
Not
can't.
blocked by me. Just want to point that out. Not block anybody right now.
I don't know. Usually, somehow, vicariously, I don't know. Yeah, Steve made these shapes, which I think is a really cool way of talking around this problem. And so something that a lot of host implementers are doing right now for a lot of these different WASI APIs, like let's say WASI key value in this case, they're embedding as part of that host layer the Redis client, which of course is the thing that's going to have all the CVEs. And so by decoupling this, especially for a use case that's around cryptography, it makes a ton of sense so that even this part here, the capability is separated away from those hosts. Yeah, okay, jigsaw puzzle pieces, yes, is how they work. And so that way, this little piece here, this green piece is that what we're discussing around as being the WASI fill, the piece that we adapt to wasmCloud and work over like wasmbus RPC. So anyways, this is yet another reason why I think the WASI fill methodology makes a lot of sense in this case.
And Bailey, let me just explain as my simple understanding then. The host is a lot simpler because we're not baking any of the stuff into each host. It's loaded, so then it's loaded on demand, which also means that it's pluggable and can be extended at runtime as opposed to baked in at compile time. So if I'm sorry, is it Yashin? Did I pronounce that right?
Almost anything works. Jochen.
Anything? So if Johan, okay, I was actually gonna troll you like you're one of my kids and say like, so if anything wants, whatever.
Joe at Starbucks. I'm Joe at Starbucks. They don't.
If Johan, for example, if you wanted to have private capabilities that you didn't share with the public ecosystem, you don't have the burden then of baking them into a custom host and forking it. You can simply just load your dynamic capability, your dynamic WASI fills at runtime. Bailey, is that do I understand this right?
Great job.
Okay, pluggable good, baked in bad.
Example for that would be a machine adapter. So we have machine controls that we would have providers for, basically.
Yeah, exactly.
Connected.
Yeah, exactly. Yeah, that's exactly I think the advantage. I've noticed across many different open source software platforms that the best of breeds always tend to be, dynamically pluggable at runtime, by the users. That you get an example like it with Brozeek, for example. That's one I worked on for a long time. You get the default capability, the default protocol analyzers, but you could always add your own at start time. So those are that's a pretty powerful approach and pattern there that's out there. But I'm glad we had a chance just to sort of explicitly talk through this for the people here and also for the the people that watch these videos later.
Yeah, this is an awesome discussion. I want to make sure that we just have time for the last little bit of the agenda, and then we can kind of get into free discussion. So the last little bit, I just wanted to do a little bit of a KubeCon wrap up. This section is really light. I just wanted to say thank you to everybody who came by the wasmCloud or the Cosmonic booth when we were in Europe. It was a lot of fun meeting you all in person. It's really cool having people come up and say, "Hey, I've heard of wasmCloud. Like, I wanted to talk to you about what you're doing." Especially like with Johan coming over, and we're talking really in depth with like Nat's things, restricting access and like different things that we can work on. I also just wanted to share the good attitude that when I was working the booth last week, I had, generally I ask people, I say, hey, have you heard of WebAssembly before? Because that kind of informs how to talk about what we're offering as a project. And, the ratio of people who have heard of WebAssembly is just steadily climbing. This conference, I think, at least 80% of the people who came over and talked with me had heard of WebAssembly before, which is awesome. And even had somebody come over, I said, oh, have you heard of WebAssembly before? And they said, oh, who hasn't? And I think that was such a cool thing to hear and measure how fast the server side ecosystem is growing here in this space. Really exciting. The only other thing that I wanted to share is a couple of links to the recordings for our talks that we did at this past conference. So I have one blog. This is actually, we posted on the Cosmonic side, but it kind of sums up all of the talks that happened on this past WASM Day, and kind of went through and added comments on each one along with the video recordings in line. So I'm just going to call out the ones that we had. First one, Evolution of WASM, Past, Present, and Future from Bailey, which is a really awesome talk. Kind of went all the way through the history through today. I wanted to call out the next talk that was with us, which is actually Jordan. This was Jordan's first talk, as I understand it, at a conference, which was really fun to watch. Jordan has a certain, he's got a charm to his talk. This was a really cool one, and also just really neat to see someone who's an expert in the security space kind of roll through the different levels all the way down that wasmCloud takes to secure an application, especially by default. Really cool seeing this in action. I had a little bit of a lightning talk. This one was really fun. It was a lighthearted introduction to WebAssembly in the form of a Dr. Seuss poem. You should check this one out. I had a lot of fun writing it, even if you think it's lame. It was a lot of fun. And then last but certainly not least, we worked with some folks at Adobe for the WebAssembly or WASM plus container Kubernetes beyond containers. They talked about some of the work that they did with wasmCloud inside of Kubernetes to improve some of the way that they're running their compute internally at Adobe, which is really cool. I think this one is the most watched talk from WASM Day. So far, it's been getting a lot of buzz, and this overall is pretty exciting. Now, the last one, which I unfortunately have not been able to watch yet, was at the main conference. It was Kevin's talk on building distributed event sourcing systems with wasmCloud. I heard a lot of really good things about the session. The room was packed. People saying it's the best talk of the conference. I won't say anything because I haven't seen it yet, but I'm sure it's great. We'll post this one to you in the wasmCloud Slack as soon as it's ready. So just wanted to do a little wrap up there, and I'll go ahead and post some links in the chat. But with that, I think we can go ahead and move on to just general free time. Anybody have any other questions from today, things from the conference, or just general discussion that they'd like to chat about? We got a couple more minutes before we'll stop the call. All right. Well, I think that'll probably wrap it up for the day. We can go ahead and stop recording, and we'll hang out for a couple minutes. Thanks, everybody.